Hey everyone, and welcome back to PrepFusion. I'm Anish, and today again I'm back with another conceptual question. So one of you guys posted this question on the Telegram group. So I don't know if this is a gate PYQ or not. So I made the question, okay, and we'll try to solve it. So in the first go, also I thought like what could be the approach. Then obviously that thing came into my mind that we had to approach it differently. Okay, I will tell you about all that. But first let's read the question. The question states that for a given OLTF is given of a unity feedback system, the damping ratio zeta is 0.707. So at the instant when the question mentions about damping ratio, you know that this is a what underdamped system. So things you should write when you write or keep in your head that things that you should decode from the question. So zeta is given, okay, zeta given, right? Zeta given 0.707. That means system is underdamped. System is underdamped, that is for sure. Okay, these two information I get, I am also getting another information, but I will tell it later. So now it is taking the dominant pole approximation. Why? Because what you observe is generally like the damping, right? Underdamped, overdamped, critical damped, all those things are for second order OLTF. But here what do I have? I have a fourth order OLTF. Okay, so obviously they are telling us to neglect the two poles that are very further away from the origin, using the dominant pole approximation. Why? Because the poles that are further away from the origin, right, they won't affect much of the time response of the output. Basically the time response that I'm getting, right, of the system, the poles that are much more further away from the origin, they won't affect that, right, the time response. That's why we can neglect those, and we can only take those poles, basically approximate my OLTF using the poles which are nearer to the origin. Okay, so that is basically what dominant pole method is, right? Dominant pole approximation is we approximate the transfer function, right? So here like it has given us the system is underdamped. Okay, now obviously we will approximate that two poles are very further away from the origin and two poles are nearer to the origin, right? So and then basically by underdamped, what do you understand? What are the location of my poles? So if my poles are underdamped, if my system is underdamped, what are the location of my poles? The locations of my poles are what? Complex conjugate on the left hand side of my S plane. So negative complex conjugate poles, negative real part complex conjugate poles. So look, like from this I can decode negative real complex conjugate poles, right? This is about underdamped. What about overdamped? What happens to overdamped? Overdamped works like a first order system only. Why? Because there also we use the dominant pole approximation. Basically we have what? Two poles on the negative real axis itself, and they are not equal. One is very further away from the origin and one is very nearer to the origin. Okay, that's why we can ignore the other one. Okay, I have you are recalling. And what about my undamped? Undamped, what happens? The poles lie on the imaginary axis itself, right? They lie on the imaginary axis itself. There is no damping component to it, right? Plus j omega n and minus j omega n. And what about my critical damped? What about critical damped? Critical damped, they are negative, but the poles are equal, negative and equal. Okay, and what are the time response? All those things I have explained in the previous one of the previous video, right? In the time response. So this question is very good actually. This question is combination of both time response and root locus, because mainly time response, this only one concept come up, right? So I will recommend obviously to solve this in the second go or third go, because this is like a combination of two topics, right? Combination of two topics. That's why this is a bit difficult question. At first go it may not click. Okay, so for us to solve this question, we'll basically need the concept of root locus. So why we need that concept of root locus? Because like you can take the hint that you have been given k value. What other method you could have used is, if a third order system would have been given, then what you could have done is, like, if let's say for example this question was like this is k by s plus 3 whole cube. Okay, what you could have done is, you could have done, let's say, k1 by s plus alpha and s square plus 2 zeta omega n s plus omega n square. Okay, now what you could have done is equated this one with this s plus 3 whole cube, and like you could have found the s alpha value. Like, why is this alpha? Because like there will be one pole that is very further away, and this is that pole. One real pole will be very further away. only one pole is there, so we will get only like we will not get imaginary complex conjugate poles. Why? Because our coefficients are real. As our coefficients of my characteristic equation are real, we'll either always get complex conjugate poles or real poles, right? We'll not get only one complex pole. Okay, we'll get a pair of complex poles which will be conjugate to each other, because my coefficient of my characteristics equation will be real, right? That is the reason. So this is that single pole that is lying on the real axis and that is further away from the origin. Okay, now this is s square plus 2 zeta omega n s plus omega n square, and you know zeta, right? And from this, if you equate this one with this, and you will be able to find out. But this is also a very lengthy process, but still it is a good process. But for a fourth order equation, you wouldn't be able to solve it. For a fourth ordered equation, you have to do something else. Okay, so like for a third order equation also, you can use the same method that I will show you now. So we will have to use the concept of root locus. And what is the concept of root locus? Let's just first draw the root locus, and from there we will understand. So basically, what were the steps? Now this is a very easy plot, right? For root locus, this is a very easy OLTF. So what was the first step? First step was the number of branches. So how many number of branches do I have? So number of branches is basically equals to P if P is greater than Z, or Z if Z is greater than P. But for a proper transfer function, my P will always be greater than Z. So P, which is equals to 4 number of poles, right? Now how many number of asymptotes or virtual zeros I have? So number of asymptotes or virtual zeros is basically P minus Z. Okay, so basically the amount of zeros that are not present. Basically I don't have any zeros, so I will have 4 virtual zeros. So number of asymptotes or number of virtual zeros. Okay, how many do I have? P minus Z, which is Z equals 0, so it is simply equals to 4. So 4 asymptotes I have. Now what are the angles of those asymptotes? So angles of asymptote, basically this is the third step, right? And in this step another thing also gets included. Angles of asymptote equals to minus 180 into 2k plus 1 divided by P minus Z into yeah, like it goes from 0, k equals 0 to P minus Z minus 1. So I will get 4 angles of asymptote because I have 4 asymptotes, right? So basically this will be first one is minus 180 by 4, which is minus 45. Then I will go 90 degrees, right? So this will be minus 135 minus 225 degrees and minus 315 degrees. So 4 angles of asymptote. Now another thing is that what are my centroid of asymptote? So whenever these types of transfer function come up, right, the centroid will be minus 3 only. Why? Like what was the formula for centroid of asymptote? Centroid of asymptote formula was minus 3, like summation of all the poles, location of poles, right, minus summation of all the location of zeros divided by number of poles minus number of zeros. So what is it? Summation of all the location of poles. It is basically what all of them are at minus 3 itself. So I have 4 poles at minus 3. So simply minus 3 plus minus 3 plus minus 3 is simply minus 3 times 4 minus 0 divided by P minus Z. So P is 4 number of poles and 0 is 0. Okay, so now this becomes simply minus 3 itself. So centroid is minus 3. It will always be like that whenever I have equation like this in the power format, right? Centroid will be in this minus 3. And one more thing you will notice, that if you try to calculate the breakaway point, right, breakaway point, you notice that my breakaway point is at minus 3 itself. Why? Because whenever there are repeated roots, right, repeated roots, then that will also cause a breakaway point, right? That will also cause a breakaway point. So whenever there are repeated roots, that will also cause a breakaway point. So I will have 2 breakaway points at that minus 3 itself. You calculate it and you will see. So breakaway point will be also at minus 3, right? So breakaway point will also be minus 3. So if my breakaway point is equals to my centroid, whenever my centroid and breakaway point are equal, then what happens? My asymptotic lines become the root locus branches, right? So sigma c is equal to breakaway point. I will try to calculate it in front of you, the breakaway point. So there were two things about the breakaway point. I will just quickly solve it for you. Equals to 0. Like this was the equation basically uh, for like 1 plus g of s. This one was the 1 plus g of s, right? 1 plus g of s is equal to 0, right? This was the characteristics equation, right? So now what we do, we write the value of k minus s plus 3 whole to the power 4. Now simply differentiate it, right? When at whichever point at which it is 0, that is my breakaway point, right, for that value. So dk by ds equals to 0, hence simply this becomes dk by ds equals to minus 4 into s plus 3 whole cube equals to 0, right? So how many points I have? S equals to what? Minus 3, right? At s equals to minus 3, I will get 2 breakaway points. Why? Because like there are 4 branches, right? So 2 branches will break away, and then other 2 branches also will break away. Okay, like that only. So that's why. So s equals to minus 3 is a breakaway point. You can understand from here also. Okay, if you want to prove. So this is true. Whenever this is true, right? Whenever this is true, this is just a concept. My asymptotic lines, become the root locus branches. What if you don't understand by asymptotic lines? I will just draw and then you will understand. Root locus branches. Okay. Now you might say, sir, this is taking so much longer for us to solve. No, like obviously during the exam, all right, you should already know all this concept. Then only you should go ahead, or you should solve it at the end if you don't know anything. If you want to solve it from the basics, right? That's why. So obviously you shouldn't solve it if you don't know anything, like at the first go. That is what I was trying to explain during the starting, right? So basically, how will my root locus look like? So my root locus, this is sigma, this is j omega, and here, right, I have 4 poles, minus 4, and I have 4 poles, that is understood here. Sorry, minus 3, and I have 4 poles. Now what are my angles of asymptote? Angles of asymptote are minus 45. Okay, so minus 45 will lie somewhere around here, right? And this is my centroid itself. So minus 45 from this, minus 45 from this. So I have minus 45. Okay, and again I have what? Minus 135. Then I have minus 225, and then I have minus 315. Okay, and all of them are 45 degrees, right? All of them are 45 degrees. That is known to us. Now if these are 45 degrees, and what are these lines? These are my what? These are my asymptotes, and these are my virtual zeros, and these are my asymptotic lines. Now what I said to you earlier is that if my breakaway point and my centroid are same, then what happens? The asymptotic lines become the root locus branches itself. So they will be straight lines also. So I can directly draw it like this. Okay, just don't go by the drawing. This is a straight line. Okay, so don't go by the drawing. This is a straight line. Oh no. So now, as this is 45 degrees, what can I interpret from this one? So what is the like we have drawn the root locus branches. Now what can you interpret? Like this distance, right? This distance is 3. I'm talking about the distance, not about the location. Obviously location is minus 3 comma 0, but distance is 3 from this origin. Okay, so if this is 3 and this is 45 degrees, so tan 45 is 1, so obviously the base is 3, then the height will also be 3. So this, right, where it cuts my imaginary axis is what? J3, because like this is on the imaginary axis, that's why J3, but the magnitude is 3. Magnitude is 3. Here also it will cut at minus J3. Okay, this will be symmetrical. Okay, so yeah, that is the point to note here. And like for underdamped system, now let us first understand what are the location of my roots for my underdamped system. So for underdamped system, what happens? Like I hope you remember the formulas. So this is sigma j omega S plane basically, and here, right, I have complex conjugate poles. So the real part of my uh, complex conjugate poles are what? They are minus zeta omega n, right? Minus zeta omega n. And imaginary part is known as the damping frequency, damped frequency. Okay, this is minus j omega d. This is plus j omega d. So this is equals to omega n. What was the formula? It was 1 minus zeta square. Okay, j omega n 1 minus zeta square. So this was the formula basically for damped frequency. Like now what I will do, I will draw those locations here because I have been given about the information about the zeta, and from that I'll try to find the value of k. How? From root locus, right? Graphically we can find the value of k. Okay, that we can do. So here what we do, like let's say my two complex conjugate poles lie in this location, right? In this and in this location. So this is minus zeta omega n. Okay, and what is this location? This is omega d, right? J omega d, which is j omega n under root 1 minus zeta square. If you don't understand like what are these formulas, then you have to revise the time response chapter. So yeah, this is this. Now how can we again use that tan theta relationship? So again, right, obviously this distance is 3. Okay, but what about this distance? What is this distance? Like up until this is 3, right? This is 3. Now what is this distance? This is basically 3 minus this zeta omega n, because this distance is zeta omega n. Okay, so this distance will be 3 minus zeta omega n. Okay, 3 minus zeta omega n. And what about this distance? This distance is same only, omega n into under root 1 minus zeta square. Now obviously if like this is also angle 45, right? This is straight line and they are increasing like this, so this is still angle 45. So again I will use the tan theta formula, that is height upon base. So if I use the tan theta formula, what I will get is, what is the height? Height is omega n 1 minus zeta square. Now zeta is 0.707 and 0.707 is 1 by root 2. I will write it like that for simplifying my calculations, divided by 3 minus zeta omega n. So I will write it like this, 3 minus zeta omega n. Okay, I will not replace, okay, I can replace zeta omega n here. So zeta is what? 1 by under root 2, and this is equals to tan theta, tan 45, which is 1. So this becomes like 1 minus 1 by 2 is 1 by 2, under root 1 by 2 is omega n by under root 2. So this is 3 minus omega n by, this is omega n under root 2, right? So this becomes like 2 omega n by under root 2. So basically under root 2 omega n equals to 3. So omega n becomes 3 by under root 2. So omega n is basically 3 by under root 2. Now what are my distances basically. So what are my distances? So if omega n is 3 by under root 2, then what I need to find? I have to find this location of the pole, right? Location of the pole. So if I want to find this location of the pole, then basically what is zeta omega n? So okay, like zeta omega n is what? Zeta omega n is zeta is 1 by root 2 and omega n is 3 by root 2, so it becomes 3 by 2. So location of the real part is 3 by 2, and obviously on the imaginary part will also be 3 by 2. Why? Because like they are following this, like this is 3 by 2, okay, and this distance is what? 3 minus 3 by 2. So this also becomes 3 by 2. So if base is 3 by 2, then height should also be 3 by 2. So this is also 3 by 2, this is also 3 by 2. Okay, that is understood. Now why is this so important? Why is this so important to find the locations? It is important because we want to find the k with the help of the graphical method. What was the graphical method? Basically, when if you want to find the value of k, right, without putting the value of the s in the OLTF or in the characteristic equation, you want to find the value of k. What you do is you uh, write the location. You stay at the location where you want to find the value of k. So I want to find the value of k at this location, right? I want to find the value of k at this location. So if I want to find the value of k at this location, what do? I like use this formula. Like this formula obviously came from a derivation that I have explained in my course. I will not explain it here. It is the product of the length of the given point to the poles and product of length of the given point to the zeros. I will just give you a brief like intuition why is this the case. So let's write it k upon s plus alpha by s plus beta. So I have a 0 and pole, and this is the characteristic equation. So this is equal to 0. So obviously for some value of k and like s, right, this has to satisfy. So let's say my s is some test point st. Okay, now what do we do? What will be my value of k for that test point st? Basically this one will go at that side. Okay, 0, this will go -1, and what do I do? I want to find the what magnitude of all this, right? Magnitude of all this. So this will have some real and imaginary component, and if you find it out, right, if you take the magnitude on both sides, you will see that just this is s plus beta, no, not this was s plus alpha upon s plus beta. I'm taking the magnitude on both sides. Okay, now this beta, s plus beta goes above, s plus alpha goes down, right? So k equals to s plus beta magnitude upon s plus alpha magnitude. Now what does this magnitude represent? This basically represents the distance of this test point from this pole, sorry, from this pole, and distance of this test point from this 0. Okay, that is what this represents. That is what the formula is written. The product, like here, since I have only one pole and one 0, it was simple. Else if I have multiple poles and multiple zeros, this will be the formula. Product of length of given point to the poles by product of length of the given point to the 0. 0 is downward denominator and pole is the numerator. Okay, so if we don't have any zeros, then obviously our denominator will become 1. So this was the basic intuition about the formula. So now I have already like drawn this root locus, right? Drawn this root locus. We have to find this distance d. What will this distance d? Simple class 8 standard formula. That is, here we have what base and here we have height, and we have to find the hypotenuse. So base is what 3 by 2, right? Because this is 3 by 2 and this whole length is 3. So 3 minus 3 by 2 is 3 by 2, and this height is 3 by 2 itself. So 3 by 2 square plus 3 by 2 square, and we have to find the, we take the under root of that. So under root 3 by 2 square plus 3 by 2 square, which is equals to what root this is 3 by 2 into root 2. So this becomes 3 by root 2, right? This becomes 3 by root 2. So my distance is 3 by root 2. Now this is the distance for a single pole. I have 4 poles lying at the same location. So what will my k become? K will be 3 by under root 2 into 3 by under root 2 into 3 by under root 2 into 3 by under root 2. Now this becomes 81 by 4 basically, so this becomes 20.25. So this is the value of k. Okay, so this question was sent by Sanjeev, I think, and I asked him I was at first glance I wasn't able to figure this one out, but then obviously he told me, sir, we can solve it using the root locus approach. So yeah, if you know any other method, right, to solve this, or if you find any other approach, then do please let me know in the comments. We can also solve this using putting that one thing that how I showed you to solve the third order equation, but that will be very lengthy. Okay, if you know any other method, then do please let me know, and I will see you in the next conceptual question. Thank you for watching.